Thank you, Tom. So I work for Qubole. We are a big data platform. I am going to talk a little bit about our platform, 2 or 3 slides, just to provide some context. But the point of this presentation, we've had clients running queries, about 200 million against our platform. We've spun up close to, I think it's 1 billion nodes. And we take metadata about those queries and those clusters, and then we do analytics against that. And so what we're going to talk about a little bit is about how companies are activating their big data and talking about what are those interesting data points that come out of that activation report that we're publishing. So a little bit about me. I joined Qubole several years ago, back when there was basically 8 of us in an office trying to figure out where we go and what we do. And again, big data as a service. So one of the observations that a lot of the analysts talk about is the potential of big data, but the reality is that a lot of them are saying it's not necessarily realized. And 15% of those from Gartner are saying they're not quite meeting the expectations. Predominantly, our belief is that it's quite hard to do, and especially historically with companies like Gartner that they're talking to have been more of the Fortune 500 that are data center driven, not necessarily born in the cloud, but have to make a massive CapEx infrastructure acquisition, a lot of effort to get the data into the big data environment itself, meaning that it is very hard and a lot of upfront commitment to make that actually happen. And what we do is we refer to this as the activation gap. So with the volume, I don't think anybody would argue about the volume of data that people are collecting these days, and it's growing exponentially. The number of use cases and the roles of data scientists and people like yourself that want access to that data is increasing as well. And then you have things like privacy and concerns. Cambridge Analytica is a great example with Facebook. Then you have GDPR as governmental regulations that are coming on board. And then users themselves wanting access to anything from raw data or curated data sets for a variety of analytics. The issue comes down to the fact that people are not increasing their budgets for it, and the supply for big data specialists is really hard. If you look at the number of recruiters in London, which is kind of shocking to me, I moved here a year ago, 2 days ago, and how many recruiters call us asking about how many hires we have happens on an almost daily basis. It's kind of stunning to me. But the point being is that they're few and far between. And so that means what can you do to enable those folks here that want to get value and drive yield out of the data, but doing it in the most cost-efficient way, and to enable them to be able to do that. And again, that's what we call the activation gap. So a little bit of background on Qubole. Again, I moved here a year ago. Basically, Expedia is a client of ours. They have Hotels.com up in Angel, in Islington. And they started as one of the several divisions of Expedia to utilize Qubole, and they wanted a local presence. So we built that out. We went from me as a team of 1. We're about 8 people now and growing as the business dictates. So we've been around since 2011. The founders of the company were the folks that published this book and created the big data infrastructure at Facebook. As part of that, the whole point of their charter was to provide basically a self-service analytics platform for the rest of the organization to start monetizing the data that they were collecting around the users, and then that led to all the advertising revenue that they're collecting. So as part of that, they created Hive to enable not just engineers coding MapReduce, but being able to basically Hive QL and make that easy for them. Let's see. Interesting note that it's close to an exabyte per month that we're processing on behalf of our clients. So I remember back in 2000 working and being acquired by Oracle, and we were talking about an account, and they called it the Terra Club account, and didn't know what that meant. And so I asked, and they said, it's one of our larger clients. They have a terabyte of data. So now we're talking about petabytes of data as relatively small data sets, too. So what is Qubole? Really quick. So it's anybody that's putting their data into the cloud, the S3 object store, the blob store in Azure, the Azure Data Lake, and Oracle and Google as well. But we're providing this analytics platform. And really what it comes down to is elastic on-demand clusters for these technologies. But then we segment it by persona. So how do we provide productivity tools for the data scientists, analysts, and the data engineers to, again, prepare data for a variety of different reasons. Maybe it's pushing it into an enterprise data warehouse or Snowflake or Redshift, providing ad hoc query capability or BI reporting, but then ultimately doing any sort of deep learning or machine learning as a data scientist. So that's us. Again, we've got about 200 clients that are utilizing the platform as well. And so the observations, here's what I was talking about earlier, where we're collecting a lot of that metadata. And the initial feedback that we're providing back to our clients programmatically is basically rules-based. But we're looking at how do we expand that and start using machine learning to get better information back to them on how they're using clusters. Things like which are the most appropriate node types to use given the current workloads, or how should you, what file formats should you use for specific queries or personas in there as well. So we do have a lot of customers that have doing this very well. And candidly, these are Qubole customers, but Oracle is an example, the data cloud. It used to be Datalogics. They got acquired by Oracle about 3 or 4 years ago. And they're seeing significant savings through automation leveraging Qubole. They've got about 100 Hadoop and Spark clusters that they're spinning up and down an on-demand basis. Lyft started off as migrating a bunch of workloads from Redshift, still using Redshift, but migrating ETL workloads into Hive, then started enabling their data scientists to do things like route optimization. And now they're using things like Presto for BI and reporting. And then Samsung, the SmartThings group, the guys that do the home automation platform, they started feeding the TV data, the Samsung TV data, into that same data lake, and didn't need to hire out to be able to do that, because the beauty of the object stores in the cloud is that it's all handled for you. You just need to, basically, I think it's about 0.23 cents a gig per month to create that. So a very cost-effective way, and automatically scaling out, which then enables a variety of users to then do those analytics against that data lake. So now, it's kind of funny because everybody that we are talking to, the data scientists, are the people that just throw them at the problem and will get great results. So, not necessarily the reality from our experience. You have to have the proper expectations on what you're going in with. You cannot sit there and apply same software engineering principles that you would for data science. It's exploration. It's not engineering. Eventually, you will get to engineering, but you need to do that exploration. So you need to set the right expectations going into these types of projects. So the way we do that is we start looking at how the maturity of our customers and how we talk to them and how we help them get started. Because given that it's the cloud, you don't have to buy anything. You don't do anything. In our world, we charge per second per node under management. So you can just get started with it, use as much or as little as you want. So we see a lot of the larger organizations, the FTSE or Fortune 500, that have been doing EDW. And they have this desire to move to big data. And so they buy a bunch of CapEx, they buy a bunch of hardware, they put it in the data center. Let's get a top-down kind of use case that's targeted, and then start experimenting with it. Now, once they get success, it's very difficult for them to expand out. So what we see is when they start moving there, this is where people start really moving to the cloud. We obviously, starting out originally, because we're just cloud native ourselves, we saw most of the companies like a Lyft or a Pinterest or a Reddit that were born in the cloud that would sign up to Qubole. But here is where companies like Expedia, where they had a 600-node cluster and a 300-node cluster on their data center, but they had all the production workloads that were taking all the capacity of those clusters. So I'm going to show my age a little bit, but my dad was telling me stories about how in university he'd have to go in at 2 a.m. into the lab to be able to get time on the mainframe. So it was kind of like that with Expedia, where there was so much workload that the data scientists weren't getting access to those clusters to actually do their job. So they were limited to the desktop and what they could do. And so what they did was carved out, they're using Kafka, and they just started streaming the data into S3. And they signed up to Qubole and just started doing data science via notebooks and Spark there as well. Eventually, they started migrating all the ETL jobs and all the prep jobs that were going along with it. But then they started seeing a lot more experimentation happening. So really use cases driven by different segments in the organization that allowed them to do that experimentation, which then led to specific products and capabilities that they brought in. Now, this usually happens for a born-in-the-cloud company a lot faster. So they'll start anywhere from just doing some basic ETL because they're putting it in S3, and they'll start doing some BI reporting via Presto, or they might do something like Spark use cases for a recommendation engine to get started, or ETL and Hive originally back in 2012. So I should note that we started off with Hive as a service. In 2014, we added Presto as a service, and then in Jan of 2015, we added Spark as a service to the platform. So as these open source engines evolved, we started adding those in because customers needed them to do specific analytic requirements themselves. We also talk about it from the segmentation of data scientists and skill sets. So it's typically your C1s are folks that are definitely just on the PC getting going with a subset of the data just to do that experimentation. They start looking into getting into then the big data, start to leverage all the different data sets. And again, this allows us to chat about with our customers to figure out what's the best way to work with them as they go. And then you have companies that are more in the deployment stage that are failing fast with experiments. We have Return Path as a client, and they have their data scientists trying new features and new capabilities within their platform, their marketing campaign, email management system. And then you have companies like Oracle I mentioned earlier, where they're creating 10,000 models a month. They have 100 clusters of different types that they're using. They have about 45 different data scientists and a couple of hundred analysts. So they buy a lot of data, and they turn that around and then sell that to other folks. So if you're, I don't know, maybe Marks and Spencer, and you want to understand that group of ladies from 18 to 34 that like salty crisps, as they're called here, then you can get that segmentation and then market to them accordingly. So that's what they do. So what are folks that are doing it well? Where do we see them really kind of getting benefit and being able to move with pace in this world? One is recognizing that the best way to do that is in the cloud. I think that's an obvious statement. Big data workloads are ideal for it. They are in state, they scale up, they are on an as-needed basis, and which lends itself very well to that cloud model. They want more and more people having access to data. They want to enable folks and not hinder them from doing it, given, obviously, certain constraints that they might have internally. But the whole idea is to, I'm going to use it, I shouldn't use it, but democratizing data, as they say. And then also, different people have different requirements and different skill sets. So being able to utilize and leverage the appropriate engine. And we're specific to a few, so we always talk about those, and that's the data that we have. But not dictating an engine based on a use case, but allowing them the flexibility to use what they need when they need it. So this is a very typical use case within Qubole. This is actually Under Armour. They just presented at a conference that we host back in the States. So taking their raw data from Kafka, from their application. So I don't have my phone with me, but it's basically Under Armour, MyFitnessPal. So it makes you input your dietary items that you've had for the day, your exercise. They help you track it so you have a weight loss goal that you would want. And so they help you meet that. And then as part of that, they also provide recommendations on exercise and diet and things like that back to you. So they're collecting JSON log files from their web application as well as their mobile app. They're doing all sorts of data preparation. They started using Qubole back in 2012 as well. So originally started with Hive and then started using Spark for those ETL jobs. Taking that Avro file, creating that derived data set, and pushing it to Redshift. They're looking at Snowflake now as well. But then also doing the recommendations that I mentioned by taking that data and pushing it into databases that are serving the actual applications themselves data scientists using Spark. They're getting into, we just enabled a deep learning cluster on behalf of our clients. It's in beta right now on GPUs in Amazon. So the idea is that as a data scientist, I can just point click, or the admin can point click and have a cluster available to them on an as-needed basis. And then they have a lot of ad hoc. So if they see anomalies in the data, a lot of times they'll just start using Presto to start looking at those and going against either the curated source of truth or back to the raw data itself. And so this is, the point being is this is what we're talking about when we say that a variety of use cases and a variety of engines that are utilized. So comparing to, I don't know how many people have come from the kind of data center world into the cloud, but this is comparing kind of your Hadoop distribution that has data locality. You have triple replication across those different nodes. This was for a Spark event, so we just had Spark on there. So, but you can put Hive or Presto on there as well. So it just makes it very difficult to scale out because you're actually purchasing hardware. You're adding it as you go. And this is also, if you were to take a Hadoop distribution and try and run it in AWS or Azure, no different. You're running a cluster 24/7, and your utilization is going to be relatively weak. In the case of the cloud with AWS and Azure, as the two that we primarily support, you just put that data in that object store. It grows. You don't have the manual effort in supporting it. But that allows you to do dynamic, on-demand, elastic clusters. Not unique to us. We've separated compute and storage. But again, it's not unique to us. There's other vendors that do it. But what that allows you to do is have that variety and that flexibility. So here, much more expensive because you're paying 24/7 for those in the cloud, or you purchase all that up front in the data center and difficult to scale. You can't really evolve it. It's a massive engineering effort to do so. It's typically very fixed or crude auto-scaling as you go. Maybe you could add a couple metrics on a very specific, add a couple nodes on a specific metric for a static threshold. But in the case of no data locality, it's much more cost-effective. The downside is this is faster, potentially, as the slide says. But there's a lot of effort from Amazon, Azure, companies like us, to make the API from the object store equivalent to, so network speed is relevant to disk speed as they go. But it's just allows you to evolve very quickly, too. So we have this notion of zero downtime upgrades, where I just clone a cluster, upgrade the version on it, save it off, drag and drop the label, and my ETL workloads just flow right through. Or if they're using a notebook, they just, from a pick list, decide which cluster they want to run that notebook against. So I'm promising not to talk too much about Qubole, but I'm still doing it. So what does that actually mean? So typically, this is coming in from that report. Typically, we see an 8x factor as people scale out on their clusters. So if I have a minimum node cluster of 20, it might scale up to 160 nodes based on workloads themselves. Based on our math, and we'll talk about how we do this, we've saved about $240 million for our clients in cloud spend in 2017. So that's through elastic clusters, only paying for what you need when you need it, as well as leveraging spot prices as well. And we'll talk about that a little bit. Not a surprise, I think, for everybody, just given the growth and the growth curve of AWS and Azure, where so many workloads are moving to it. I mean, we've talked to many of the big banks from insurance companies that have a cloud-first strategy and being able to take advantage of the subscription model of a cloud, use it as you need it. So this is an interesting one because this is, as Microsoft, this is Amazon Spot instances. I don't know if you're familiar with them, but it's essentially a secondary market inside Amazon for EC2 instances. And in late 2016, they created this Spot Fleet API, which means that I can buy, based on node type, the most appropriate priced Spot instance. And it's usually about a 70% discount off of on-demand. So it's a huge savings for our clients. With that Spot, the downside is they can take it away at any point in time. So there's this risk-reward that goes along with it. But things like Hadoop have a lot more durability built into them in Hive. Spark is getting there, and Presto is relatively new. So you're slowly starting to see incrementals into those engines to be able to handle that Spot takeaway. But we've built a lot of automation in it in the product as well. So what does this actually mean is that we can take advantage of, through automation, that secondary market. So again, always focus on, I would argue the cloud providers are very good at getting you to utilize their resources. I would argue, too, that they don't do a very good job of helping you do that in the most efficient manner. And that's where third-party vendors like ourselves really try and focus and bring value to our clients. So many of our clients that we talk to, or prospects I should say, want to get to the point where they provide self-service, and that's the ultimate goal. The challenges that go along with it, we talked a little bit about that earlier, but a lot of it's due to just having a kind of a legacy view, more of an enterprise data warehouse view of that world, where you have this choke point, the data team, that is responsible for curating these resources and getting the asks from the different business units on access to those data, but being in between the data infrastructure itself. We, like many, are trying to get to the point where the data infrastructure is elastic and can be leveraged across an organization, and doing it in a very easy manner. So the data team focus more on the platform, and because, again, it's software-based inside the cloud, you can automate it with software, and being able to then elastically grow based on the needs of the different user constituents in an organization itself. So what does that actually mean? For us, it's 200 million queries that have been executed against it, Qubole itself. The automation also means that, and this is an extreme, the 1 to 188, where I have a single administrator with a ratio of Qubole users. So the goal is to be as efficient and always trying to help our clients get to the point where that number is as efficient as possible for them. So the idea is that anything that we can do around automation to enable that broad access, still managed centrally, because a lot of things like GDPR and security requirements still exist, but doing it to the point where it's very simple for the data team to be able to enable. This is interesting, too, because as I mentioned, we started off with Hadoop and Hive as a service. We added Presto based on requirements that our customers were having. They wanted more of an interactive, fast data exploration, data discovery capability. And then I mentioned Spark coming around in Jan of 2015. But the growth of folks that even started off with Hadoop have now evolved to using all three. And then folks that started coming to Qubole just using Presto. So an example, Shazam does Spark on EMR, Amazon's native platform. But they would see these anomalies in the data, in the aggregates and summaries that got pushed to Redshift. And they wanted to explore those. So they just signed up to Qubole, started using Presto as that single engine, but then started using Spark as well. So they're using all of them, continuing to use Spark, I should say, on EMR as well. So it's not a be-all, end-all. But the whole idea is that I should be allowed as a user to evolve how I want to use those different products. So I don't know if you're familiar with these. I probably should have had them in a different order given how we supported them. But again, very focused on ETL. We have still a lot of clients that are using it because it doesn't make sense to migrate those jobs over, but they also are moving from an on-premise world into the cloud. So they can basically, if they have that Hive Metastore, they migrate that to AWS. And then they just take those workloads and start running those against a Qubole cluster, or in some cases, EMR cluster too. Apache, I don't think we need to talk much about Spark, given the audience, but then we are starting to see Presto. If you're not familiar with it, it's an open source in-memory engine for ANSI SQL for doing very interactive queries. It's basically supported by Facebook. It came out of Facebook. But companies like Netflix, Uber, Lyft, Reddit, they're all using it extensively. Twitter is a big contributor back to open source for it, too. And it's, again, all open source. So this one is just talking about the growth of those engines themselves. So I was kind of surprised by the Presto one, given we've had it in production. It is the highest growth, but it also had the lowest base. So, but it originally was not the most stable thing in the cloud. The Facebooks of the world, the Netflix guys, they're using it in an on-premise cluster, Uber too. And since it's in memory, it has issues that are associated with it and trying to make it as stable as possible. So Things like if you don't get your join ordering correct, it could completely hose the cluster. And so the open source community now is adding features back in, including us, contributing a bunch of stuff to improve the stability of it. And you're starting to see that use grow as a result. They also have data analysts that are SQL folks that know it well, know SQL well, and so it's a natural progression for them to start using it too. And that's where, again, some of that growth is coming from. So if we are starting to see the growth in total commands run, obviously, against all of those. But with Presto, it's an interactive engine. So you're seeing a lot more volume happening as a result. Whereas in Spark, you're doing a lot of the machine learning or ETL jobs that take a lot of time that go along with it, and same with Hive. So the volume of those clusters and commands are a lot different based on the requirement. So this is just the number of users that have been increasing in the use of it. And again, this is, it is Qubole data, but we work with Netflix and Uber and Twitter, Facebook as well. They just presented at the data conference that we sponsor back in the States on their contributions back to Presto and that community as well, and then Spark too. So we're seeing a lot of people merge out of the Hadoop world and Hive and wanting to move into Spark and get into the data science role as well. And this just talks again about what we see. I mentioned it's the extreme at 188 for the large-scale implementations, but it's a range. So we have small startups that are doing, started off with just ETL work to get their data and start to show some critical KPIs back to the business. Started to build out a team, started using Spark. Poshmark is an example where I think they've taken about $30 million in funding. It's a stylist application, mobile app. And they're doing really complex, really interesting things, like based on users interacting with the system, they're dynamically building out their web page. Expedia is doing something very similar. So this is the point being that you have access to a lot of this capabilities, but you don't have to make a massive commitment to it. And again, it doesn't have to be to Qubole either. You can sign up to EMR. You can sign up to HD Insights in Azure. There's a variety of different ways. We would argue that we do it in the most efficient manner, as you can imagine. Our argument would be, but you do have options and you do have choices. Actually, Hotels.com will cut and paste a Spark job out of Qubole and run it against EMR. They do the same thing with Hive. And that's the beauty of these open source platforms, just to make sure that they're getting the maximum utilization out of the specific engine or the specific vendor itself. So the beauty of S3 or the Blob Store or Azure Data Lake is that you have choice. You can evolve easily and move and grow on an as-needed basis. So some of the other trends that we're seeing within the platform, I don't know if you're familiar with Airflow, but it's a Python-based orchestration kind of scheduler workflow engine. We're seeing that growing consistently and considerably over our client base for a lot of the ETL type workloads. So that's one area that we're seeing. XGBoost within our client base. Pandas, obviously, for Python. And then TensorFlow, I mentioned we have that new deep learning cluster that we've enabled for a couple of clients. It's still in beta. So it's right now a single node so that you can start doing anything from TensorFlow on Spark to get started, or native TensorFlow. So Activision Blizzard, if you know Call of Duty, we're collecting and analyzing all that data. But they're doing model testing on a single GPU to figure out how to interact better with their gamers. And the whole idea behind it is moving away from shipping a physical disk to driving more digital revenue within game as they grow. So that's all I had. But the whole idea is allowing you to pick and choose what you want when you need it, being able to enable different user constituencies, and then ultimately trying to do that in the most efficient manner. So making sure that you're only paying for what you need when you actually need it, but having all the automation to still allow the team to focus on a data platform with those self-service capabilities. How are we doing on time?
Thanks, Tom.
Yep. Any questions?
Any questions?
Any questions? That's better. Thank you.
No, so I got a question. Are there any of the companies that are large enough that are doing the sort of large banks or something where it's cheaper for them and still more productive to do use sort of in-house databases rather than to ship it out to Google because they can afford the skills to do it?
Yeah, we actually have had a couple customers that have what we refer to as churn because it got so big. And the AWS bill more appropriately. So for every dollar they'll spend on Qubole, it could be $3 or $4 in AWS spend. So there's a couple of folks back in the States that have insourced it and brought it back into their data center. So yes, that has happened.
Are you able to say, are they large, what sort of scale are you able to say? Or?
Yeah, it's, I don't know the actual numbers themselves, but it was several, if not close to double-digit petabytes per day. So more social applications, Silicon Valley. And there they have a lot more resources. Like everyone is flocking to the Valley. So they're, it is very expensive because you have Facebook. We compete with those guys on resources, and it's astonishing some of the packages that people are getting. Good for them, great for them. But yeah, that does, it definitely does happen. We're seeing it more where people are now, I don't want to sound like a Silicon Valley snob here, but we're seeing it like a year or two behind. And so people are starting to really look at how can we leverage the cloud. Our point is you should use it as you need it too. It doesn't have to be all or nothing. They make it very easy to get that data up there. And again, data is a classic example of a use case that's perfect for the cloud. Yeah. There's two more.
You hinted at some things that data scientists might do to annoy their platform team by doing joins in the wrong order or trying to shove too much data through a different kind of technology. Can you share? You shared some best practices. Can you share anonymously, of course, any common worst practices that people like me would be using on your platform?
I think most of them come from Presto, less Spark and less Hadoop. If you write a bad query in Hadoop, more than likely it's going to finish, but it might take a day or two. So there's a bunch of things you can do around join reordering there. In the case of, and this is something that we're contributing back to open source, where rather than, Presto doesn't have a cost-based optimizer in it. It's been in the community for 3 years. They haven't done anything with it, and we're starting to see people jump on the back. A lot of argument happening. But the whole join reordering is an example where if I have my massive table as my first, and then I try and load that up into the cluster, it's going to completely hose everything in there. So we've implemented join reordering and are pushing that back into the community. We're doing dynamic views and dynamic filtering back into the community itself too. So we're trying to make it so it's automation as opposed to, because no matter how many times you teach somebody, I'm not the smartest guy in the world. I need to hear things 3, 4, 5 times before it really sticks. And the same thing was happening with our clients. So we would, the other one is notebooks, where they would be creating these massive notebooks and having the expectation that they would return within minutes for these jobs, but if you look at what they're actually doing. So it's more expectation management on that front as opposed to technology there as well. Does that answer your question?
Good enough, thank you.
All right.
Any more questions? Okay, round of applause for Tom. Thank you.
Yeah, cheers. Thank you.
There is something really nice about saying round of applause for Tom.